Why do we feel heavier or lighter on different parts of the Ferris wheel?
Imagine an object moving in uniform circular motion. Usually, there's a force that acts on the object that pulls it inward and actually keeps it rotating. This particular force, we can call it Fc, and that is equal to the centripetal force. So the centripetal force is the force acting on an object in uniform circular motion that pulls the object inward, or that keeps it moving in the circular path. Now there's a force that is felt by the object that makes it feel like it's pulling it outward. So this particular force can be called the centrifugal force. So the centrifugal force is the force acting on the object that makes it feel like it's going outward in the uniform circular motion. We can actually use the example of a person in a Ferris wheel. At the bottom of the Ferris wheel, if you notice that your weight actually feels a lot heavier than it is, while at the top, the weight usually feels lighter. This is because, according to Newton's second law, the forces acting on the object, the weight, and then the normal force, right? But then we know that the person is moving in uniform circular motion, which means there's also a centripetal force acting on the object. So we can use Newton's second law to say that the summation of the forces is equals to the mass times the acceleration. But here the acceleration would be AC, which is the centripetal acceleration. And looking at the summation of the forces here, we have the normal force and then the weight. So the normal force minus mg is also equals to mac. The person will actually feel the normal force. So we can write this as normal force is equals to mac plus mg. This is what will be felt when the person is at the bottom of the Ferris wheel, which means they will feel a lot heavier than their actual weight. At the top of the Ferris wheel, we know that there's the centripetal force. Now the centripetal force will be acting downward, which is still inward in the circle. Then we also have the weights and then the normal force. We can still use Newton's second law. At the top, the summation of the forces is equals to mac. But now, since it's down, it's going to be negative. Then it's still the same thing. You can say summation of the forces is normal force minus the weight, and that's equals to negative mac. Since it's going to read the normal force, that would be normal force would be equals to, bring this here, mg minus mac. So this is going to be a lot smaller than if it's just the weight. So that's why a person at the top feels lighter, while at the bottom of the Ferris wheel it feels a lot heavier.